ready for takeoff.
Thank you for coming. My name is Caleb Hearth, and while I usually prefer to keep my introductions brief at the beginning of talks and talk employers and promotion and all that stuff later, since you're already here and I don't have to actually convince you to come, and we're probably all here for the same reason. But in this case, I do want to touch on my background because it helps to underline the point of my talk. I've worked in Ruby on Rails for about 10 years. And across that time, I spent about 5 years each at product and consulting companies. I currently work at TestDouble, a consultancy specializing in embedding within software teams to help build better software and better teams. And previously, I worked at Thoughtbot across a variety of greenfield and established Rails apps. You can find me on my blog online, where I write about various programming concepts like ethics, best practices, and testing. And since the bird site is done now, you can find me on Mastodon at dice.camp/@Caleb, or just by searching Caleb Hearth. Throughout my career, I've had the opportunity to work in dozens of apps, each with their own test suites and strategies for testing, and that's given me a chance to compare a lot of different ways of writing tests. One little let and a tiny bit of before often seems like a good idea, but I've seen them grow organically into these spider webs of complexity that are very difficult for not only new members of a team to grasp, but for grizzled veterans to reason about as well. Let defines a memoized helper method. Give it a name and a block to execute, and it'll execute that block 0 or 1 time, depending on whether you call the method, store the result, and return it. On subsequent calls, it'll return that stored result without executing the block again. If you dig into the definition, it's almost exactly defined as a plain Ruby method. A let method can be referenced by other lets. And depending on the nesting, that reference may be to a different method definition in different specs. Subject can also reference let methods. Speaking of subject, they're basically just a let block with special semantics, since there are some methods, like it is expected to, that use the subject name implicitly. You can also give subjects other names while maintaining those same semantics. But effectively, subject is just a let method named subject, so every time I say let, I mean subject as well. A before block is executed before each spec that it is in scope for, which is to say, any describe or context block that contains both the spec and the before block, regardless of how deeply nested, will execute the before block. Now, I'm going to use before here to stand in for after as well, because they behave exactly the same, just at different times, and the same thing for around. A before block can reference let variables or any other methods that would be in scope for a test, including subject or let methods. Now, I apologize. Hopefully, you can see some of this. I overestimated the contrast that a projector and bright lights can handle. So let's take a look at an extreme but real example of one reason that let and subject are problematic. This is a 4,500 line unit test for the God object of an app I once worked on. Before I started the project, I began to refactor it. It makes heavy use of let, not just for the main model, but for many other methods as well. Drink that in. In 4,500 lines, there are 531 let definitions across 131 different method names. 78 of those are overridden in different describe and context blocks. 9 of those are redefined at least 10 times, with a maximum number of redefinitions of 69. Nice. In addition to that, there are 87 times that subject is defined. And in almost every one of those cases, the type of the subject is different from the original definition, which is to say that some method or attribute of the system under test or a collaborator is being referenced as subject and not the system under test itself, and that the subject is returning a different type of object in different specs. Overall, almost 14% of this file is dedicated just to let and subject lines, not including multi-line blocks where the values are actually being defined. Much of this structure is front-loaded in the spec in place to support an extremely complex general fixture. General fixture is one of the root causes for obscure test, which simply means that it's difficult to understand at a glance. General fixture is the term, and obscure test are terms that Gerard Messeros uses in X-unit test patterns to describe when a test builds a larger fixture than is necessary to verify the functionality in question. In Ruby and RSpec terms, at the beginning, you can see that white block up at the beginning. There are 31 let definitions in place to parameterize the default subject instance. This is all set up that is not needed for most tests, but because one or two describe or it blocks needed to reference some behavior, all specs in this file now need to do that work unless they define their own simpler subject. This is harder to visualize, but the majority of these methods are also defined such that they're only used in a single spec. They'd be so much simpler and clearer if they were inlined into the it block. Needless to say, it's quite difficult to reason about given a let or subject method, what it contains and where to even find it. It isn't uncommon in this file for a let or subject to find hundreds of lines in several block scopes outside of where it was being referenced. When I was refactoring, I had to jump 350 lines up to find the correct lets. Now, I wanted to share all of this because as we move into a more contrived and more manageable example for the amount of time we have to refactor, we should know that in the real world, there are test suites that look like this. And in fact, in my experience, this is where most specs that use the majority of RSpec trend toward over time. Our goal should be to have manageable, understandable, and maintainable tests that we enjoy adding to and making changes in. So we have a situation where we're defining a method, which let and subject both are, just with extra steps. But it's hard to track down because they're done through these macros, and they're intentionally easy to redefine. Beyond the navigation issue, these methods construct themselves by referencing other let variables. And across different specs, those delegations are referencing different methods, what I talked about with the different contexts earlier. While the code seems to be doing the same thing across different specs, it's in actuality running through completely different code paths that are being used, and it's very difficult to track that. Finally, especially in the case of subject, it's common for the actual type being returned to change between different describer context blocks. You really have no idea what you're dealing with when you call this method. So what are our options for refactoring out of this? Perhaps the simplest option is to simply replace a let with an instance variable. For example, let book could be at book. Well, this technically checks the avoid let box and may be slightly more performant than a memoized lookup method. It maintains a lot of the same issues, specifically that they're likely to be overridden or defined differently in different contexts, so there's little chance of finding the correct definition for a given text in a spec of even moderate complexity. Another option that solves part of the problem is to change these let and subject definitions to properly defined Ruby methods. This involves memoization via instance variable or equals some calculation of the value. And doing this improves the odds that automated introspection tools, such as C tags or language servers, are able to find the correct definition. The approach does not help with the second part, which is that these are being redefined in different contexts. So depending on their nesting, you're still dealing with different methods. The third, and the one that I recommend here, is the inline method refactor. This method was originally named by Martin Fowler in refactoring, improving the design of existing code. And it's pretty straightforward. Instead of pulling these variables into a let or subject, define them directly in the test. But Caleb, I hear you saying, this is repeating yourself. And we don't repeat ourselves, that wouldn't be dry. This is a point that's a common simplification of don't repeat yourself. Andy Hunt and Dave Thomas in The Pragmatic Programmer stated the dry principle as, every piece of knowledge must have a single, unambiguous, authoritative representation within the system. One of these words matters here, knowledge. The goal of dry is to avoid duplication of knowledge and not duplication of code. Now, it turns out that duplication of knowledge also tends to reduce code repetition, but that's a side effect and not the primary purpose of dry. It's often simplified to new programmers, myself included, that they are learning about dry as deduplicating code, even though this helps with deduplication of knowledge. It leads to premature extractions of code that need to be then parameterized to support different use cases. The default version of subject, which is defined as described class.new, or more concretely in our example, book.new, is really more of an indirection than a consolidation of knowledge. Book.new is already a method. Writing it into a subject doesn't dry anything out. But even if it did, in the case of tests, I'd argue that knowledge deduplication is not necessarily a good goal. I've called these tests specs because colloquially, that's generally how I've heard them referenced. But RSpec actually defines them as examples. And I'm glad that it does because it points that the code that you're writing should look like how it is used. David Bryant Copeland recently wrote, RSpec examples are, well, examples. The article's thesis is that avoiding predicate matchers, such as expect order not to be sent, should be avoided in favor of expect order sent to equal false, which is a good point. I have to say it's a good point because unlike Gerard Messeros, Martin Fowler, or to a lesser extent Dave Thomas, David might actually be in this room, or at least at the conference. But taking David's point even further, it's desirable for each example to be a self-contained example of how to reproduce behavior. RSpec example, real world example. Following that pattern, given any individual RSpec example, in isolation, we have all the knowledge to reproduce the behavior specified in the example in the code base itself, or in our own code if this is a gem or some other shared code. Drying tests, imagine that I had a nice visual here of like taking code from a spec file and into, but I didn't have time. Drying tests reduces the utility of each example by relying on shared utility methods, or worse, unshared utility methods that convolute what's actually happening in the tests. If you can't look at an example and understand what's being tested, how the system under test is intended to be used, and be confident that it actually works, then your example is not really living up to its full potential as living documentation. So my advice for test setup is to write everything twice, or hopefully more than twice. Embrace that there may be a bunch of setup that's duplicated between examples, because these examples are documentation. Doing this setup inline allows you to write only what you need in the test, and not to build out fixtures that support multiple things. It also shows the difficulty of using your code to surfacing the collaborators, the arguments to the class, and other setup that's required to be in this environment before you can even run the code. Complexity introduced in the name of decreased repetition of the code does not make your specs better, and it's not a worthwhile trade-off just to hide test setup. If something's difficult to test, that's a smell that you're either testing the wrong thing. For example, you might be testing the return value of another unit tested method in another class. In that case, you can safely mock out the collaborator and just pass the return type that you need, because you can be confident that the other class is working correctly if its tests pass. Then you can have a single integration test that proves that they work together. Or it may be that your object has too many collaborators and may be able to be refactored to avoid a complicated setup by reducing its fan-in, or number of collaborators that it relies on. Since Mastodon is the cool new place to be and is a Rails app, I thought we could take a look at a portion of its tests for our refactoring example. Here's the full spec for the mute bang method, split into 3 columns to better fit on a slide. This is a test of the mute functionality of an account, and if you'd like to follow along later, it lives in spec models concerns account interactions spec.rb. I know that you can't read any of this text. That's OK. I'll be talking through it as we go and use bolding and color and some animations to help draw attention and help you understand what's happening at the macro level, even though line by line you won't really have any idea. So we can see that the spec overrides the default subject, and that it's used 9 times here across about 100 lines of code. Subject is a good place to start when we're refactoring out of this, because when it's used at all, it's used in almost every example. As I mentioned, we can use the inline method to take the body of the subject definition and place it directly into the body of each spec. Thanks to scoping, even though the subject definition referenced account, target, and arg notifications, all of which are let methods, the code will continue to run here and have access to those methods. One thing to take a look at is that these tests have a very similar and non-flat structure, which can be an indication that they may be testing more than one thing. So taking a closer look, we can see if there's any overlap. Each of these tests have this check, expect mute to be a kind of mute. It looks like each of those are using an expect a change block to send the mute message and then checking this return type. So this is an optional refactor. It's unrelated to letter subject, but we can take this opportunity if we want to remove that duplication of the type check. Zooming back out, we can run these tests to ensure that they pass. I did, they do, don't worry about it. Then we can continue to inline let methods. Hide notifications and arg notifications are a couple of let methods that are similarly named because they're being passed as keyword arguments of similar names. So they're adding confusion just by existing, as opposed to being inline in the calls. So let's inline them right away. Doing that means we no longer need these context blocks because they're no longer providing a place to define those let methods. So we can flatten them as well and just take the meaningful context in their text and append it into the it descriptions. Now we can inline this. I like this part of it because it looks like this is going to be much shorter. Don't worry, it won't be. We can inline this mute into each spec as well. And because it's used in this before block, we'll go ahead and inline that now as well. Note that at this point, we're moving some actual code into specs, which was obfuscated before. That hide notifications flag that was previously being set in each of these context blocks is now correctly set in the spec. So as you glance through this spec, it's easy to tell at a glance without needing to find the hide notifications method name, which is highlighted like a method name and not a Boolean, and then search backwards, hoping to find the right definition to find whether it's true or false. So I'm going to fast forward a bit and inline the last couple of lets, account and target account. These are going to seem like they're coming from nowhere because, like the original example I showed, these let methods are defined hundreds of lines away from where they're being used. This particular file is only 650 lines as opposed to 4,500. But it uses these lets all over. And luckily, it doesn't override them at all, so it's easy for us to determine which ones to inline in this case. It does beg the question as to what benefit they're providing by not being inline to begin with. We're able to make the inline definitions in place of methods in some places. And in others, we use local variables to replace the method definitions so that we can use that same name to make assertions against. So let's take a look at one of those refactored specs. This is the before example. It's extremely terse. It tells us almost nothing about what we're testing. We can kind of tell that we're making expectations about a subject. Recall that this is a test for a concern called account interactions, so we don't actually even have a class that would make some educated guess about what the default subject would be with described class.now. The innermost expectation is that we're returning a mute, but where that comes from, why it would be a mute, we really have no idea. To find that, we'd need to scroll up in this file about 55 lines to the definition of subject, which is far more than is what's going to appear on most of your screens. We're also checking that a mute doesn't change its hide notification setting. Where this mute is defined, what its context is, or how it's related to the subject are completely opaque to us. We also know that the be kind of expectation is checking a return type, and that expectation is duplicated 9 times in this file and is unrelated to the main purpose of this example, which is to test that hide notifications flag. Finally, we have no hint that there's code being executed as part of a before block in this block before it's ever run. After our refactor, the test is understandable in isolation. Every piece of context, every piece of work, every hidden step that was previously elsewhere in this large file is now here, so we can understand and read through exactly what's happening. For a lot of the same reasons as let, I recommend avoiding before or after or around in most cases. However, at the global level, I think it makes a lot of sense for running things like database cleaner to run all tests and transactions, webmock to disable outbound network connections, and anything else that's going to be run for every single spec, or even for an entire category, like any subdirectory of spec. It's probably OK to be using it before there. The smell comes when you're doing things that are scoped to some describer context block, even though, or even a spec file. At the risk of repeating myself, it makes sense to repeat yourself in order to have understandable tests. Avoid hiding excessive setup in some block so that it seems like things are simpler than they are. What's worse about before than let is that it's additive rather than replacive, a word that I looked up just so that I could use it here. Whereas redefining let or subject will not execute the code that would have been defined by the method on that name outside the current scope, before, after, and around will combine. So this can lead to a lot of setup code that's happening outside of the scope of your test you're running, and can be difficult to track down what all of it is. Shared examples, shared context. behaves like, and similar RSpec tools have the same problem as let or before, since they're almost certainly using those tools. But additionally, because they need to use indirection so they can be reusable, they have the additional problem that they explode the complexity of code because they need to be run every single time they're included. So they may be being run and running all of their before blocks and all of their let blocks and all of their around blocks a dozen times every time you include them because they're being included in multiple places. These hide complexity in the name of decreased repetition and often require a lot of their own setup to be used. Again, I'd recommend moving the important specs for each class inline into the main spec files rather than trying to extract them using these tools. And for things like a module or a concern, rather than testing that every single class that uses a module behaves as if it does, try to test it directly or possibly generate a test, an example implementation for the test that can be used to exercise the module and serve as a reference to show you exactly what your dependencies are. So in summary, use RSpec, but only the good parts. Don't use let, don't use before, and don't use shared anything. Once again, I have been Caleb Hearth. Thank you so much for coming to the talk. And if you'd like to ask questions or discuss RSpec, Test Double, Mastodon, Dungeons and Dragons, please do come find me in the hallway. I also want to thank my employer for sending me to RubyConf this year. If you've ever felt frustrated when you get stuck on a problem, we want to help with that. Let us know what topics you wish there were more resources on, such as talks, blog posts, or screencasts, by taking this survey. Test Double loves pair programming because it can help us to get unstuck. If you'd like to pair with a double agent, please request a free virtual pairing session with a Test Double developer at this link. Thank you very much.